Alright, today we're going to break down a really elegant cloud automation pattern. Seriously, this is a game changer for anyone managing infrastructure, especially when things start to scale up. Let's dive right in.
So picture this. You start with, say, 10 servers. No big deal, right? You can keep track of that, but then your app takes off. Suddenly you're looking at 100 servers, then 1,000. How in the world do you keep track of what's running, where it's running, and if it's even healthy? It gets chaotic, and it gets chaotic fast.
And that's really the heart of the problem we're talking about today. The absolute chaos of managing a server fleet that's constantly changing. You know, trying to use a spreadsheet or some manual script you have to run, that just isn't going to fly. It's slow, it's begging for human error, and pretty soon you've got massive blind spots in your own infrastructure.
Okay, but what if we could flip this whole problem on its head? Instead of us desperately trying to track every single server, what if each server could just announce its own existence? What if it could just report on itself?
Now, this idea of a self-reporting server is not some kind of magic trick. It's actually made possible by a core component that's built right into every major cloud platform. So let's pull back the curtain on the VM's secret weapon, the Cloud Metadata Server.
So what even is this thing? Well, the best way to think about it is like a VM's own internal ID card and its personal GPS all rolled into one. It's a special service, and this is key. It's only reachable by the VM itself. And it holds this treasure trove of information about that specific machine, its identity, its configuration, everything.
And how does a VM talk to this service? It uses a special, non-routable IP address, 169.254.169.254. You should probably remember that one. Think of this address as like the secret handshake. It's the universal key that lets a VM figure out who it is, whether it's on GCP, AWS, or Azure.
A VM can pull all sorts of useful data about itself. Its name, what zone it's in, the project ID it belongs to. But out of all of this data, there is one piece that is the absolute superstar of this entire pattern, and that's the unique ID. This is a non-repeating identifier assigned by the cloud provider, and it makes every single VM perfectly, uniquely identifiable.
Okay, so we have a way for a VM to know who it is. That's cool. But how do we turn that into a fully automated tracking system? Well, it really just comes down to two key ingredients. Let's break them down. So, ingredient number one is that unique instance ID we were just talking about. We grab this straight from the metadata server. And this isn't just any old ID. It's guaranteed to be unique across the entire cloud platform. We're going to use this as the primary key for our records, which completely wipes out any risk of mix-ups or overwriting the wrong server's data.
Our second ingredient is just a central place to store all this info. And for this pattern, a NoSQL database like Google's Firestore is a perfect fit. And here's why. Because it's a document database, we can give every single VM its very own document. Think of it like its own file folder. And the label on that folder? You guessed it, it's that unique instance ID. It's a perfect one-to-one mapping.
So, we've got the ID and we've got the database. But hang on, how do we get the data in there without having to manually create a record every time a new server spins up? Well, the real magic here is in a single super powerful database operation called an upsert.
Okay, this is where it all clicks. We use one single command, an upsert. So when a server tries to report its status, the database basically asks one simple question. Hey, have I seen this server's ID before? If the answer is no, boom, it creates a brand new record for it. That's the self-registration. If the answer is yes, it just updates the existing record with the latest info. That's the self-monitoring. One single action handles both jobs automatically. It's so elegant.
All right, let's put it all together now. We've got all the pieces, so let's actually see the machine in action. I'm going to walk you through the entire auto-registration flow step by step. Here we go. First, a new VM boots up and immediately runs a startup script. Second, that script pings the metadata server to get its unique ID. Third, it uses that ID as the key for its document in our database. Fourth, it performs that magic upsert we talked about, writing its status as, say, running along with the timestamp. And finally, that's it. The VM is now officially registered and tracked in our central database. And the best part? This entire dance happens automatically for every single VM you launch with zero human intervention.
So that's the how. It's pretty cool, right? But now let's zoom out from the mechanics and talk about the why. What are the big picture wins you get from this kind of self-reporting architecture?
Oh, the payoffs here are huge. First, you get massive scalability. This pattern works exactly the same whether you have 10 servers or 10,000. It's fully automated, which means you can say goodbye to manual tracking and dramatically reduce human error. You get a single source of truth,
one centralized real-time dashboard for your entire fleet. It's also more reliable because each VM is responsible for its own status. And, maybe the best part, the core logic is totally cloud agnostic. This pattern works across GCP, AWS, you name it.
Look, if you remember one single thing from all this, let it be this idea right here. Each VM is responsible for tracking itself. We've completely decentralized the work of reporting, which, kind of ironically, creates this incredibly powerful, centralized, and reliable view of our entire system. It's a total shift in thinking.
And this is where it gets really exciting. Because what we've built here isn't just a simple tracking system. Nope, this is the foundation. This is the bedrock you can use to build much more advanced systems. Things like smart auto-scaling, self-healing infrastructure that automatically replaces bad machines, and really sophisticated health monitoring.
So yeah, that's the whole pattern. We've seen how a pretty simple idea, a quick query to a metadata server and a clever database operation, can solve a really complex and chaotic problem at scale. Which really just leaves one final question for you. Now that your servers can report their own status, what will you build?